Welcome back, everyone. Before the break, I defined what a polyhedron is. I defined what volume is, and just a reminder in case you've just joined us, the volume of a three-dimensional shape can be calculated by finding the area of the base and multiplying the area of the base by the perpendicular height. So please make sure that you know that that is the definition of volume, as it is slightly different to other definitions like surface area. Then we defined what the volume of a cube is, a rectangular prism, and a cylinder. Now we're going to get into some examples where we can apply what we've seen with volume. Let's go to the board. So the first question has asked us to calculate the volume of the rectangular prism. So we've got our rectangular prism present over here, and we have been given the 3 dimensions that are going to help us to achieve this. So let's just remind ourselves of how I'm going to actually calculate the volume of this shape. I always have to take the area of the base and then multiply it by the height. So the base is this bottom base rectangle, where we can see it has a length of 12 centimeters and it has a breadth of 3 centimeters. So I have first calculated the area of this rectangular base, and that is the first part of the volume calculation. I am then going to multiply it by the perpendicular height. Because I've been told that it is a rectangular prism, that means that all of these corner angles are actually at 90 degrees, which is good news for me because this means that this 4 centimeters represents the perpendicular height of the rectangular prism. So I'm going to have 12 times 3, then I'm going to multiply it by 4. This means 12 times 3 times 4 is the same thing as 12 times 12, which is just going to give me 144 centimeters cubed. Please take note that I have cubed my units. Just a reminder, for area and surface area, my answer is always with the units being squared, but with volume, it will always be the units cubed. The cubed indicates that it holds a capacity, it holds a volume. So we've written centimeters cubed because it is a capacity. So please remember that, keep that at the back of your heads. I really don't want you to lose a mark because you forget the cubed. So centimeters cubed. Great, let's look at the next example. So we are now going to calculate the volume of this specific cube. Now, before anyone gets worried, it might look slightly overwhelming that there's only one measurement present on the cube. But what is a cube? A cube is a 3-dimensional figure made up of squares. And I know that all squares have equal sides. So that means that each of these sides, everywhere you look, each side is 5 centimeters. So with measurement questions, please make sure that you read your question carefully, because the fact that this is a cube is your immediate first clue that I actually know what my dimensions are of my shape. So the volume is the area of the base, and I've got a square base, and the area of a square is length times breadth, so it's going to be 5 times 5. And volume is always the area of my base times my perpendicular height. And squares have right angles at all of their corners, so that means that this height present over here is perpendicular to the base. So the perpendicular height is 5. So the volume will be 5 times 5 times 5, which is just 125. But am I done, guys? Can I leave my answer like that? I'm hoping there's some shaking of heads. No, I've forgotten my units. So it's going to be centimeters. Is it going to be squared or cubed, everyone? Cubed, because it holds a volume, which means it can hold a capacity. Let's look at the next part of this question. So it says if each side of this cube was decreased by 1 centimeters, what would the new volume of the cube be? So this question is essentially asking us to look at what we've been given. We've been given a cube where each side is 5 centimeters. Now they've said, 1 second, hold a second, wait up. We're now going to decrease each of the sides by 1 centimeter, and we're going to have to calculate the volume according to this decrease in size. So if each side is originally 5 centimeters, we know that if we remove 1 centimeter, all of the new sides will be 4 centimeters. So let's see what our new volume will be. So it's no longer 5 centimeters. We now have 4 centimeters for each side. So that means again that each measurement will be 4 centimeters because it is a cube, which means that all of the sides are equal to each other. So I first find my area of my base, which is the square at the bottom. Length times breadth will be 4 times 4. And then we are going to multiply the 4 by 4 by the perpendicular height. And the perpendicular height, we again know that it is a right angle because it is a cube made up of squares. The perpendicular height is 4. And 4 times 4 times 4 will give me an answer of 64 centimeters cubed. Great, I hope everyone's with me. Let us go on to our next example. So we are first going to calculate the volume of this cylinder. Please note, guys, it will be given that this is a perpendicular height, and you will be needing to look out for the fact that it is the perpendicular height. So we're going to calculate the volume of the cylinder. We've been given the radius, and we have been given the perpendicular height. So let's do this calculation. So we know that the volume of a cylinder will first be calculated by taking the area of the base. My area of my base is pi r squared, because that is the area of a circle. My radius is 3 centimeters, so it's going to be pi times 3 squared. So I first found my area of my circular base, where my radius is 3 centimeters. I'm then going to multiply this by my perpendicular height, which is 8 centimeters. Wonderful, guys. So now we are going to need our trusty friend, the calculator. So we are going to type in pi. Just a reminder how to get the pi on your calculator. You press shift, and then you press the button that says times 10 to the power of x at the bottom, and that gives you your pi. So it's going to be pi times 3 squared times 8, which gives me 72 pi. But if I want to simplify this into units, I press my SD button, and it's going to give me 226,19. And I've rounded to the second decimal place. In your test, you'll be following the instruction with regards to the rounding that you need to use. So it's going to be 226,19 centimeters cubed. Again, we're saying cubed because this is a volume. It has a capacity of 226,19 centimeters cubed. Great. Let's have a look at the next example. So we have been given a can of cool drink. You can imagine whatever cool drink it is, maybe you have a favorite one, so you can keep that in the back of your heads. And please stay with me and don't get distracted about the thought of a soda. So a can of cool drink has measurements as shown in the figure. So we have 11 centimeters for height, and we have a diameter of 7 centimeters. So we're first going to determine the volume of the can. After we've determined the volume of the can, we are going to see how many cans can be packed into a box with a length of 28 centimeters, a width of 21 centimeters, and a height of 22 centimeters. Great, everyone. So this question has two parts. I'm first going to calculate the volume that my can of cool drink can hold. Then we've kind of been thrown a bit of a curveball. I've been given a box, and I want to know how many cans of cool drink can I actually fit into my box. So we're first going to work out the volume of the can, then we're going to see how many cans will fit in my box. So let's do the calculations together. So determining the volume of this can be done by first finding the area of the base and then multiplying it by the height. My base is a circle, and I have been given the diameter. But this is going to cause a problem because my area of a circle is pi r squared, and the volume is multiplied then by the height. But my issue is it's an r. I've been given the diameter. I cannot substitute in my diameter in place of r. But can I find my radius from my diameter? I can, because the radius is half of the diameter. So I know that my radius will be equal to 3,5 centimeters. So my volume will be pi times 3,5 squared multiplied by my height, which is 11. Great, so let us pop this in our calculator. So we're going to type in pi times 3,5 squared multiplied by 11, which is going to give me 539 over 4 pi. But I want to be able to write this with respect to the second decimal place. But guys, please make sure you read your instructions on your test to check if it's you rounding to the first decimal place or the second decimal place. And I'm going to have 423,33. I'm rounding it off to comma 33 because there is a 9 to the right of the 2. So 423,33. Cool, guys. So we know that the volume of this particular can is 423,33 centimeters cubed. Let's go on to the next part of this question. Great, everyone. So the second part of this question, I'm just going to repeat it again for us. So it's how many cans can be packed into a box with a length of 28 centimeters, a width of 21 centimeters, and a height of 22 centimeters. So before we actually start with this example, I'm going to ask us to actually imagine this box, and we are going to think about the dimensions of it. So we've got a length of 28, we've got a width of 21, and we have a height of 22. So what I'm going to ask everyone to think about is, with regards to each dimension, how would I be able to actually fit this specific can in? So if I'm focusing on the length first, we've got 28 centimeters. And if I'm going to be packing my cans vertically, I want to see how many I could fit lengthwise. So if my diameter is 7 centimeters, I would be able to fit 28 divided by 7 into the length of this box. So it's essentially saying how many cans across would fit. And 28 divided by 7 gives me 4. So I know along the bottom length of this box, I will be able to fit 4 cans. Now I'm going to look how many cans would fit with regards to the width of the box. So we're now talking about that 21 centimeters. So let's look at the width. So we're going to have 21 centimeters, but the cans are being packed vertically. So again, we're going to be using my diameter because we want to see how many cans can go across the box. So everyone, if you're struggling to visualize the box, Just imagine it's a box of cool drinks and the cans are being placed into it. So I know that the diameter is going to affect how many I can put along the length and the width of the box. Because if I'm packing them tightly next to each other, the widths of the can matter, because I need to know how many I'm actually going to fit into the box. So let's see how many we're going to be able to fit along the width together. Great, everyone. So because the width of the box is 21 centimeters, I'm going to divide this by 7, which is the diameter, and 21 divided by 7 is going to give me the fact that I can fit 3 cans along the width of the box. Now let's have a look at how the height is going to be affected. My height is 22 centimeters, but my cans themselves have a height of 11 centimeters. So that means I can fit 1 can on top of the other. So that means that I'm going to have 22 divided by 11. We're dividing by 11 because the height of the can is 11. So we're going to be able to stack 2 cans on top of each other along the height of the box. Lastly, I need to see how many cans will be packed in total into the box. And I'm just going to multiply these 3 values together, because I know that those are the dimensions of the box, so it will account for how many cans I can fit in. So it is just going to be 4 times 3 times 2. 4 times 3 times 2 is 24. So I can fit 24 cans into my box.